Hey guys, and our last piece of our limits unit here, we're going to look at the answers to your difference quotient 1 practice that you should have already done. So if you would go ahead and get that out and compare your answers to mine to see which questions you need to maybe retry and stick with a little bit longer. And then we need to go one more step with it, and this will be the last piece before we can move on to the limits assessment and just move on to some other more basic algebra that will help everybody out, whether you're doing calculus next year or college algebra. And that is, and this is going to be the easiest part by far, but conceptually it's important for those of you going into calculus. So I mentioned in our last video about the difference quotient and what it was. And the difference quotient is really just when you take 2 points and the second point is scooted some distance to the right. Most people call this h. Some textbooks call this delta x, which just means the change in x. But I'm going to call it h. That's the more common one. And so this point would be whatever this x value was plus however much it scooted over, and his y value would come from plugging in x plus h into the function, and that gives us the slope, or we can get the slope of this line by doing the slope formula, which is just rise over run. And when we plug these things in, we discovered the difference quotient, and then plus x minus x, these cancel out. So that's what the difference quotient is. It is the regular old slope formula with some generic points, x, f of x, and x plus h, f of x plus h. Well, the calculus piece is, so to get these answers on the left, questions 1 through 6, you applied the difference quotient and then you simplified it, whether that was a polynomial like questions 1 and 4, which often requires some foiling, some distributing, some combining like terms, or if there were some square roots and you had to multiply by the conjugates like question 2 and 5, or if after you applied the difference quotient you had some complex fractions and you had to deal with the complex fraction to simplify, like question 3 and 6. All of these had a final step of dividing by h, so that kind of helped us check our answers. But what you really just practiced was the algebra part of a calculus question. This is the algebraic part of the answer. But in calculus, what we're really trying to figure out is what is the slope. I mean, very rarely does anyone care about the slope of this line. In calculus, we want to know what's the slope at this instant right here. So in order to do that, what we need is we need this h value to get smaller and smaller and smaller. We need the second point to be, the closer it is to the first point, the smaller h is, and the closer you get to the slope at that instant. So if we take the difference quotient and then throw out in the front, what if h approaches 0, which we need a limit for that? You end up with what's called a derivative, which is a very, very important part of calculus. Lots of real-world applications with that. Even in some of the physics courses we have at the high school, derivatives can be used, and I think they're necessary. Occasionally, I think you might be able to have other formulas that are a little more complicated to help you get the same answer, but ideally, this is what you want to do. If you can do the algebra of the difference quotient, and then you understand what the limit part is, then you can get those derivatives. So what I would like you to do, and again, this is super simple, so if you're not careful here, you're going to miss what you need to do. But for question 1, we did the difference quotient part But now, what if I took the limit of that as h approaches 0? And if you remember, that last step of the difference quotient was to divide out h's, and that's what's keeping it from being in the 0 over 0 indeterminate form. So it's not going to be an indeterminate form anymore. So all we have to do is do direct substitution, plug in 0 everywhere there's an h, and this is what's called the derivative. The derivative is like a formula that would tell you the slope at any given time. So normally for a function we talk about f of x. When we talk about a derivative, we just use this little prime mark here to signify that it's the derivative. And so for this original question 1, if you want to graph that in your calculator, and let's say like what is the slope when x is 0? Well, you could just plug 0 into the derivative and see that you have a slope at -4. So at that instant, the rise over the run is down 4, right 1. But same equation. What if I wanted to know what's the slope when x is 1? Well, you could just plug in 1 into the derivative, simplify this, and you get that the slope at that instant is 2. So we're able to calculate exactly how fast or slow the graph is increasing or decreasing at any value of x simply by knowing this limit part and being able to simplify the difference quotient part. So the part that you will be responsible for and what you need to practice is now with question 2. Go ahead and take the limit of what we got as an answer, the limit as h approaches 0, and then do that for 3, 4, 5, and 6. And if you would, go ahead and pause the video, work those out, and then unpause the video to check your answers. Okay, so I've got my answers highlighted for you to check and compare with. So as we've seen with limits, once you get it out of indeterminate form, which you already did that work when you did the difference quotient, really almost all of it is just plugging in 0 for h. So this one on question 2, since it's written out here, when I plugged in 0 for h, I ended up with a square root of 3x minus 5 and a square root of 3x minus 5. So really the only combining you could do is to say that you had 2 of those. So you plugged in 0 for h each time, and then very, very little reducing. This one, 4 over 2 became 2. This one, -6 over 2 became -3. Went ahead and reduced my fractions, but again, the difference quotient is the bulk of the work. But if you are signing up to take calculus next year, make sure that you do understand why you're taking the limit as h approaches 0 and what you're finding, because that conceptual part of what we're doing will help you out around the 3rd or 4th week of next year when you get to that. All right, that's all I've got for this video. So go ahead and finish up what you need from this, rewind if need be, and go ahead and move on to the next part of the assignment.